All right, so we are now back for topic 2 of lesson 2, and we are going to talk about infinity as a vertical and up and down movement. And just as in the last section, we wanted to be careful not to think about infinity as a numeric value, but as a movement towards greatness. We're going to try to keep that same definition in the back of our minds as we talk about this next section. As an example, here is a fun graph for you. It is the graph of 1 over x squared, as you can see up here in the upper left-hand corner. It has this kind of interesting volcano-like shape. It starts down here almost at 0, not quite. It's really approaching a horizontal asymptote, and it's going up, 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 and as we kind of predicted in the intro here, it is moving towards infinity, vertically speaking. We also have a branch over here on the right that again starts out towards 0, and as it gets closer and closer to the center value at the origin, 0, 0, it's growing towards positive infinity as well. So we want to discuss how this sort of graph, how we talk about it using limits and some of the symbolism that we have discussed to this point. So let's go to our window right here. What we're discussing right now is the function of 1 over x squared. And we want to think about how we can label what we see. Remember, what we see is like this volcano-like shape going up, 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 and then from the right it's coming back and going up, up, up towards infinity. So in this case, I'm not saying what's the limit of this function as x approaches infinity. Well, I could. Actually, why not? Let's talk about that. What happens to this function as x goes to infinity? Well, plus or minus infinity, actually. As it goes towards positive infinity, this graph is approaching 0. And as it goes towards negative infinity, this graph is also approaching 0. So we could say the answer to this, whether it is plus or minus infinity, the answer is 0. However, we can also say that the limit of this function as x approaches 0, actually, we need to say from the right hand, this is a little symbolism we'll talk about in a second, and as x approaches 0 from the left hand. We're going to talk about that in a second, of the function 1 over x squared. So let's, again, go back to the graph. We have a function that we're trying to think about what happens as it moves towards 0, but in order to think about it in its fullness, we have to think that from the left-handed side we have a motion. We call that approaching the limit as x goes to 0 from the left side. So it's like a negative, but you put it in the upper right-hand corner. So it's called from a left-handed limit. And we also need to think about the fact that the graph is approaching separately from the right side. So we need to think about the limit as x goes towards 0 from the right-handed side. So that's called a right-handed limit. So if you want to write that down, this is a left-handed limit. Oops. And this is a right-handed limit. So what is the value of this function as it approaches 0 from the right hand and the left hand side? These are two separate things, not to confuse you. It could be the limit as x goes to 0 from the positive side or the limit as x goes to 0 from the negative side. But either case, the answer is positive infinity. So as we move towards 0 from either side, the answer is infinity. How cool is that? Well, I should say the function, right? The limit is as it approaches 0 from the negative side of the function equals infinity, and the limit as x approaches 0 from the positive side equals infinity. And so here we have not just a limit that we are trying to approach infinity and find a numeric value for, but we're actually trying to approach a numeric value and finding an answer, a solution of infinity. Now, before we finish this section, I want us to look at the graph of 1 over x so that you see why the whole left-handed, right-handed thing is so critical. And it's not just kind of an excuse to write extra symbolism. There is a real reason why it's important. So let's go here to our graph, clear away all my messiness here. I am going to change this function. Let's see if I can, let's rename it. Oh no, I don't want to rename it because we want to keep it x. Let's just delete this and start over. So we're going to call this new graph y equals 1 over x. So we talked about 1 over x squared. That was the most recent one. This is the graph of 1 over x. Now let's center it here. Notice that we have the limit as x moves towards either positive or negative infinity. In either direction, the answer for this function, let's call it f because that's what it's called here at the, where am I? Yeah, right up here on the top. So the limit as it approaches negative, plus or negative infinity of this function is 0. So that's what we know as far as moving this way, moving that way, it's approaching 0. That's the material we discussed in topic 1. But now let's look at what's happening. Let's say the limit as x approaches 0 from the negative direction or from the left hand of this function. And we're going to try to figure out what that is. And then we're also going to look at what's the limit as x approaches 0 from the right-handed direction or from the positive side of this function. What is the answer? Okay, so here's the function. Approaching 0, here's 0. As we move towards it from the left side, this whole graph is headed down to negative infinity. So that as it approaches from the left side, the limit is approaching negative infinity. However, as we're moving along this graph and approaching 0 from the right-handed direction, which is our question over here, we are actually headed up towards positive infinity. So again, let's go back over here so we aren't scribbling all over everything. The limit as x goes towards 0 from the left side for this function, 1 over x, that's our function, right? The answer is negative infinity. The graph moves down, left side down. On the other hand, the limit as x goes towards 0 from the positive or the right-handed side of this same function goes towards positive infinity. So I think you've got it at this point. But here's what's important. Moving towards positive infinity, moving towards negative infinity, direction matters. Moving towards even a value when infinity is involved, like a vertical type of infinity, moving towards even a specific number like 0 or 1 or whatever, the left motion versus the right motion has the potential to be important. Not always, because in the graph of 1 over x squared, it didn't really matter. But when we looked at the graph of 1 over x, that left-handed versus right-handed limit is going to be really important. Okay, so that's all we have to talk about in this topic video. You have one more short topic video at the end here that will be topic 3, and I want to discuss how these things relate to horizontal asymptotes, vertical asymptotes, end behavior, things like that. You may have kind of picked it up as we've been talking about topic 1 and 2, but let's formalize it in topic 3 and then you'll be all set for lesson 2.